project focusing on our understandings of ecosystems. Throughout this project, we've worked on caring for both our heterotrophs and autotroph populations while also maintaining the ecosystems which these organisms depend on.
An ecosystem is a community of living organisms that interact with one another to ultimately form a small part of life. We set up a small ecosystem that most people would refer to as a fish tank. Just like a real ecosystem, there are factors in our tank that depend on each other to survive. The other factors in our ecosystem are maintained and controlled through several aquarium system and parts. Our heater is a primary part of life in our tank, controlling the temperature in our tank and maintaining levels that fit the requirements for our healthy autotrophs and heterotrophs. Currently, our heater is set around 80 degrees Fahrenheit. Our filter and filter box controls the amount of dissolved oxygen the heterotrophs in our tank require, while also cleaning our water, which is done through a 3D printed filter redesign. Our substrate or gravel is also a part of our aquarium parts. The gravel keeps our fish conditions healthy through multiple ways, like acting as a source of filtration for our fish waste and excess food.
Cleaning and maintaining our fish tank is necessary to achieve a healthy ecosystem. Weekly, we clean out our filter. The process of cleaning the filter is simple. We remove our 3D printed filter from the filter box and then head to the sink where we will take out the sponges to rinse, removing debris that the sponges filter out of our tank water. Scrub off any debris or algae that has accumulated on the printed filter. After all components are cleaned, we put the sponges back in place and then the printed filter back into the filter box.
Bucket is used for water changes and is meant to hold wastewater that comes out of our tank when we do a water change. We will first begin by lowering the siphon into the water and filling the tubes with water to remove any excess air. We will plug one of the ends and place it into the wastewater bucket. A siphon effect is created through this, where water is lifted from our tank and dispensed into the wastewater bucket. Excess materials such as food or algae build up beneath our gravel. This is solved by plunging one of the ends inside the gravel to remove the excess materials.
We'll use a bottle of dechlorinator to remove chlorine from water we will use to refill our tank. See, one of our members is putting in a set amount of dechlorinator into a black bucket. This bucket will be used to carry the water from the sink to our tank.
When the algae accumulates on these tank walls, we use this metal scraper to scrape the algae off. Occasionally, we use the scraper to also scrape off salt.
Heterotroph population, we have guppies and corridors, although now our corridors are dead, leaving only our guppies as a heterotroph population. Regarding our guppies' needs, they need a temperature ranging from 79 degrees to 82 degrees. Additionally, we have to rotate from feeding them dried bloodworms and freshwater flakes.
Fish become stressed and require a place to hide. These three decorations act as hiding spaces for our fish to relax and return to the normal state they were before.
For one of our autotrophs, we have a hanging pothos. For our hanging pothos to be healthy, the roots of our pothos has to be in the water. Additionally, the water temperature has to be in a range of 65 to 80 degrees. It also needs a proper amount of sunlight for the pothos to grow properly.
Valsneria receives energy from sunlight and receives nutrients from the surrounding water. As we can see right here, our Valsneria is planted within the gravel. The gravel helps keep the Valsneria in place, preventing parts of the Valsneria from breaking away.
To properly grow, the Nana also needs a good amount of light to perform photosynthesis. The Nana would also prefer water temperatures ranging from 72 degrees to 82 degrees Fahrenheit.
Ammonia is waste exerted from the organisms in the tank and is the first part of our nitrogen cycle.
Nitrite is the second stage of the nitrogen cycle. Certain amounts of nitrite can be harmful to our heterotrophs. Therefore, we depend on the aquatic bacteria, Nitrospira, to convert nitrite into nitrate.
Nitrate is the third part of the nitrogen cycle, converted by nitrite into nitrate from the bacteria Nitrospira. When nitrate is too high, we perform a water change, which lowers the amount of nitrate in our tank for our organisms' well-being.
Salinity is the measure of salt in our water, and dissolved oxygen is the amount of oxygen dissolved in our tank's water.
pH is a measure of acidity and alkalinity. Temperature is the abiotic factor that expresses how hot or cold something is.
Our older guppies tend to be much more interactive compared to our younger guppies. They occasionally chase each other around, and they are the first to eat when we feed. Though our younger guppies usually swim around together, they don't usually directly interact with one another. They usually go into the gravel and aimlessly swim around the bottom of the tank, looking for food.